Salam and welcome everybody. Today we're going to solve this paper, which is 2021 October, November, and it's variant 3 for chemistry and paper 1. So let's start introducing on these papers. By the way, this paper that comes in 2020 has been changed to only one type of equations, which is like this section A, as we can see, right? Then section B is not included in that. The way of solving these equations, I will show the equation first, then you'll pause the video and you will try solve it and then compare your answer with mine. So let's start with this question. This equation seems very easy, okay, and at the same time, once you find any easy questions, you have to put in mind it could be a trap. Okay, so you have to think a lot in this answers, any questions. So let's read it carefully. The question says, the mass spectrum of a sample of neon is shown. The relative abundance of each peak is written in brackets above it. You have this beautiful, amazing spectrum. The question says, what is the relative atomic mass of AR of this sample of neon? Perfect. We just noticed that we have a rule for that. And the rule says, you will take the abundance timed to the M per E. This mass per charge, which is M per E or M per Z. It's the same idea. Okay, so you will take the 100 in here and you multiply it by 20. Okay, and then you will take the next one here. By the way, we have 3 isotopes of this sample. Since you have 3 peaks, 1, 2, 3. You have 3 samples, 3 isotopes. And then you will have 0.3 times the mass here is 21 plus 8 times 20 over what? According to what you say, it must be over the summation of the relative abundance that you have. Then the answer will be 100 plus 0.3 plus 8. It's not over 100, okay? Put in your mind. It's over the summation of these ratios. You have to sum this and this and this, then it must be in the denominator in here. After calculating all of this stuff, the answer is 20.15. Then the answer is A. But if you calculate it in terms of 100, okay, instead of this, then the answer will be D and it will be a big trap for you, okay? So the answer here is A. Good. Let's skip to the second or jump to the next question. Pause the video until I find the solution and check and compare your answers with mine. The question says 2 grams of ammonium nitrate decomposes to give water and single gas. What is the identity of the gas? If you were asked about the identity of the gas, you have to put in your mind, they're asking you about the MR because it's a good identity for elements and compounds. So, first, this is a mole question, then you have to put in your mind a chemical equation. But how can I write the chemical equation? You have to construct a chemical equation. You will say NH4, NO3. According to the questions, it says decomposes, okay, to give water, H2O, plus gas. I don't know this gas. All right. So, what are the masses? It says that you have 2 grams of this material. All right, and you have a 0.9 gram of water. Then the mass of this material here is 1.1. Okay. So, how can I find the MR of this compound of X? So first of all, you have to put in your mind, you need the MR of X, but you have the grams, then you need the moles, right? How can I find the moles of this material? Put in your mind the equation should be balanced, but we don't know the gas, which is X. We don't know the identity, so how can I know the number of materials? If you go again here and look at the choices that you were given, you have N2, N. It means that none of these products contain hydrogen. Then the total number of hydrogen in this equation is 4. According to the choices that you have, you're pretty sure that there is no water, or let's say there is no hydrogen in X, then the only number of hydrogen in the whole equation is 4. For this compound, which is water, you have only 2 hydrogen, then you have to change them to 4 by multiplying it by 2. Okay, you can calculate the moles of water. Okay, you have the mass of water, moles. The moles of H2O is the same as mass over the MR. So you have 0.9 divided over 18. Then the answer is 0.05. Then according to the equation, which says that you have only single gas, it means that the ratio here is 1. Okay? All right. So what to do in this case? How can I determine the moles of X? First, you will notice that you have the moles of water, and the ratio here is 2 moles of H2O to 1 mole of X, which is unknown for us. The moles of water here, as we can see, 0.05, and here we have X, which is unknown. Then, let's see, the moles of X is 0.05 divided over 2, which is 0.025. Then these are the moles of X. Then you have the moles of X, you have moles, and you have grams. Then you can say 1 over 1 divided over 0.025. Then the answer here is 44. Then you're going to choose that which of these gases has MR of 44. So if we start with the first one here, which is NO, it says no, by the way, by itself. Nitrogen is 14 and oxygen is 16, then it's not, this is 30, so we can cancel that. If we go for NO, 2, which is 14 plus 32, and then it's 64, then it's not the question that we need, or let's say the answer. If you look at this is 14 times 2 plus 16, then the answer is 44. Then actually, it seems that, yeah, C is the correct answer, and this is the way of thinking. Yeah. All right, so this is the way of thinking. I just want to recall it again. First, you have to establish an equation. Okay, you have the moles of water in here, and you have the moles of water, and you have the ratio between water and X, which is 2 to 1. You calculate the ratio, you calculate the mass, the MR, and this is the whole story in this case. Okay, I'm gonna get rid of this stuff, and let's go to the second question. Okay, so here the answer is C. So let's start with this question, which is a 3, and you can pause the video so you can try it by your own. The question says, which of these elements has the highest fifth ionization energy? According to what we remember, it means that you're gonna have, let's say, shells, and then you could have, let's say, 4 electrons. Okay, so once you get for the 5th one, you must be closer to the nucleus, and that's why you will have high fifth ionization energy. Thus, you start thinking like probably or for sure that you have element that is in group 4. So we can exclude P and N because these are not in group 4, so you have silicon and carbon. But you have to look furthermore, which of these has, let's say, a less number of shells, which means that closer to the nucleus. So according to what you notice, for silicon, it has 3 shells since it contains 14 electrons, but for carbon, here it has 6 electrons, then you have 2 shells only. So for sure, if we have silicon in here, you will end up with the 3rd shell and go off to the 2nd shell. But here, if you get rid of the electrons in the 2nd shell, you'll be closer to the nucleus, more than silicon. Then it will be stronger attraction and less shielding. Then A is the correct answer. Let's jump to question 4, and before we start solving it, pause the video so we can find this correct answer with each other. So the question says, the ion X plus 2 has the same electronic configuration of atom Kr. So Kr is a noble gas, and if you go to the periodic table, you will notice that it has the electron number of 36. So according to what we see, the ion X plus 2 contains 36 electrons. But the question says, what is the electronic configuration of X? Which means the atom. Okay. So if this atom lost 2 electrons to have 36, then the atom contains 38 electrons. Perfect. So if you want to write the electronic configuration of this atom, which is 38 electrons, you will start doing the notation that we used to, which is 1s2, 2s2, 2p6, 3s2, 3p6, and then we go to fill 4s first, 2 electrons, and go back again to 3d to have 10. Okay, then we can say like 4p, okay, 6, and actually we go to fill 5s2, and actually there is no electrons for 4d. Okay, so now we have an element, or let's say an atom, with electronic configuration of 38. So this is the first shell, this is 2. If you look at this electronic configuration, you will notice that it's big. Like, yeah, it's big. So how can I make it smaller, okay, to make life easier, you know? Like, yeah. So we can use the noble gas notation. The noble gas notation that indicates that you will find a suitable noble gas, any noble gas. Let's go to the periodic table in here. You can choose any of these that helps to decrease the number of electrons, or let's say decrease the line of 1s2, 2s2, blah, 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 you know the story. So according to what we see here, the argon atom is chosen in here. Okay, so how many electrons are in argon atom? The argon contains 18 electrons, which means I can cancel the first 18 electrons from this and replace them by argon. What do you mean? I can say we have 2 electrons here and 8, and here we have 8. Then we can cancel this term completely and replace it by Ar, since all of these contains 18 electrons. Okay, so instead of writing all of this stuff in here, we can write it like Ar first. Then we can fill it the rest of these atoms, as you can see. By the way, you can use any noble gas you need, but you need to use the one that takes the great number of electrons, so you don't write a lot after the quotation in here, or let's say after the notation. Then you will start ordered all of these stuff together after the argon. But in this case, we care about the order of being filled first. So we can say which of these orbitals is filled first, which is 4s. Then you have to show me that you have to put 4s2, and then 3d is coming next, and then you can complete it like 4p6 and then 5s2. So according to the answers that we have, B is the correct one. Okay, so suppose that you need, let's say, to use another one, let's say use another noble gas. You have to use a noble gas that has a number that is below 38 to start filling the orbitals. So if you need it, you can look at this here, and you notice that you can use by the way, you can use the krypton, like 36, but you will fill it later on and just like add 5s. By the way, you can do it like this, Kr, and then add 5s2, so it works. Yeah, life is here. Okay, so let's go and jump to the second one here. By the way, this one is not included in the syllabus, but according to your knowledge, you should be able to solve it. The question says, which type of interactions exist between water molecules, okay, H2O, and a metal cation? You have ion in here, okay, in aqueous solution. So suppose that you have water in here. So suppose that you have water, okay, and you have 2 lone pairs, and you have a metal, let's say, suppose that metal like M+. So what is the interactions? So according to what you see, hydrogen is partially positive, this one, oxygen is partially negative, and what is the interactions in here? So according to the choices, let's start with first one. It says dipole interactions. No, it's not a dipole. The dipole word indicates that you have partially positive and partially negative, okay? So this is only partial, okay? So we can say this is a dipole, but the metal plus is not a dipole. So we can cancel A. Hydrogen bonding, no, it's not hydrogen bonding. Ion dipole interactions, yeah. You have ion, which is the cation in here, and you have dipole, which comes from the oxygen, then the answer is C. Okay. Let's go and find number 6, and it says that which substance shows the greatest deviation from the properties of an ideal gas under room conditions. The greatest deviation means the stronger attraction, okay, the higher pressure, blah blah, So according to the gases that you have, the only one that has hydrogen bonding is ammonia. And ammonia has hydrogen bonding, strong attraction, then we have great deviation, then the answer is D. We neglect neon because it's a noble gas, it's only monoatoms, it has low interaction. And hydrogen is the lowest one, okay, the lowest deviation, the closest to be ideal gas, since it has small, let's say, IR. And for carbon dioxide, the type of intermolecular force is not hydrogen bonding. It's not stronger as in NH3. Okay, so let's go to question 7. Question 7 seems very hard and complicated, but actually it doesn't need any, let's say, way of doing a lot of calculations to reach to the solution. So the question says, in order to determine the enthalpy of the neutralization of a strong acid and base, you have this volume and this concentration of sodium hydroxide, and it was added to this volume and this concentration of hydrochloric acid, and the increase in the temperature was, like delta T was 12. In a second experiment, the same method is used, but 50 of 2 molar of sodium hydroxide is added to 50 of 2 molar of hydrochloric acid. The question says, what is the increase in temperature in the second experiment? Apparently, you're gonna get to say we duplicated the volume in here, okay? And then you will duplicate the temperature, and then you go C, and actually it's not correct at all. So you have to use a logic just a little bit. Put in your mind, NaOH and HCl in the first experiment, they have a ratio of 1:1 in volume, with the same concentration. And in the second experiment, you still have the same concentration and you still have the ratio of 1:1. So we're supposed to have no change in the change in temperature. So the change in temperature is 12 degrees Celsius, okay? Let's go to see number 8. It says, which questions represents the enthalpy change of atomization of iodine? Okay, go to your book, page 93, and just remember and recall the definition of enthalpy change of atomization, which says that a gaseous atom, 1 mole of a gaseous atom from element, okay, at standard conditions. So let's start, which of these give us a product of 1 mole. So we can cancel B because we have 2 moles, we cancel D because we have 2 moles. We have 2 choices in here. It could be A or C. But it says that according to the definition of a standard enthalpy change of atomization, it's the enthalpy change when 1 mole of a gaseous atom is formed when it's formed from its element under standard condition. We notice that iodine as a gas comes from element, but the element must be in a standard condition. So what is the standard condition of I2? It's solid, right? So we can exclude A because it's a gas in here, we don't need it. So the answer here is C, because iodine is in solid case that gives 1 mole of gaseous atom. This is the story. Okay, let's go and jump to 9, which is all about, I think, oxidation reaction and redox reactions. It says zinc atoms can be oxidized to zinc plus 2 ions by dichromate, and you notice that the chromium here has oxidation number of +6. In acid solution, the chromium is reduced to chromium +3 in this reaction. Okay, which equation is correct? Okay, so first of all, you have zinc that will be oxidized to Z and +2, and you have dichromate, which is Cr2O7 -2, that will be changed to Cr +2 +3. How can I deal with such equation, and how can I work with it? So the first step in here, let's start balancing the first equation. In here, we start balancing the number of atoms, okay? We have the same number of atoms, and then we add electron, most positive term, which is 2 electrons. So this is done here. Let's come here. So first we have to balance the number of atoms. We have 2 chromium here, we have to multiply by 2. And then we have 7O, then we have to add 7H2O. Okay. All right, and then we notice that after adding 7H2O, we have to add 14H plus. Perfect. And then we have, how many electrons we have? We have the total number of a plus 6 in here, and here we have 14 minus 2, then it's 12. So we add electrons to the most positive term, then we add 6 electrons here. So once you add 6 electrons to the left part, the overall, or let's say the charge in both, will be plus 6, which is good and everybody happy. You notice that the last step must be here. 2 electrons must be the same as here. So we multiply the whole equation by 3, and you have 3, and we have 3, then it will become 6. Then we add all of these electrons overall. So the product here is 3Zn plus 14H plus Cr2O7 minus 2. All right, to give 3Zn plus 3 plus 2, Cr plus 3 plus 7H2O. So which of these equations represents this equation? Okay, according to what we see, the first one is not correct because zinc is not multiplied by 3. Let's do it here. It's not multiplied by 3 in here, okay? And here it's not multiplied, then the answer is C, okay? So this is the answer. You can have a look at the questions and the answers as well. Okay, let's go to another tricky question. And the tricky question says, the question shows the H2 gas and I2 react to form an equilibrium mixture. Wow, we have equilibrium. Yeah, good. And we have delta H, which means this is X, so it means that the heat is in here. Okay, a mixture containing equal amount of H2 and I2, which means this line represents both H2 and I2 because these are identical, they have the same concentration, you know, like all of this stuff. It's made at the temperature T1 and the composition of mixture is monitored, and then you give, and then you had this graph. The experiment is repeated at lower temperature T2. Okay. Perfect. Which new graph would be obtained? First of all, you will start thinking like, yeah, we're gonna make it at lower temperature, then it will be less steeper, and you can do it like this, and yeah, probably you're gonna do the same thing here. But you forgot something. This reaction is reversible, and you decrease the temperature, which affect on the equilibrium of the reaction. So look at these. First of all, if like a normal student, or let's say a student who understand the rate of reaction and stuff, they will say it will be, let's say, D, for example, or I don't know. Yeah. So let's start thinking, how can I start dealing with such equation? So this is exothermic. It produces heat. Okay. And at lower temperature, the reaction in this case, at lower temperature, it will shift to the right to compensate the disturbance and the equilibrium. Then what you conclude, or let's say what will happen to the concentration of I2 and H2, it will decrease very much. Okay, it will decrease lower. I mean, like the amount, or let's say the molar fraction of I2, which is the same as H2, will decrease as well. So we're supposed to find the line that decreases a lot in here. Okay, so which of these indicates the lesson? We just noticed that it's the same. No, we have a change in the molar fraction. Actually, it decreased a lot. We have a change on it decreased a lot. In here, it indicates that the concentration increased, and actually it's not right. No, so the answer here is B, because we have a great decrease in the molar fraction of I2 in this case.